So 2.3 part 1. All right, 2.3 part 1. We are going to talk about today long division of polynomials. So let's go back to 3rd grade. Okay, we're going to go back again. We're going to go back to 3rd grade. I'm going to say we're going to divide, thank you, 119 divided by 3. Okay, the process of long division with just numbers and the process of long division of polynomials is the exact same thing. You just have to be a little more organized. If you were going to divide 3 into 119, you would say 3 goes into 1, and it doesn't, right? So 3 goes into 11 how many times? 3. So now we do what? We multiply 3 times 3, we get what? 9. Then we subtract. 11 minus 9 is 2, yeah? And then what do we do with the 9? We bring it down and we do the same thing all over again. We say 3 goes into 29. How many times? 9. Then we multiply. 9 times 3 is 27. We subtract. 29 minus 27 is 2. What is 2 called? Our what? Remainder. Okay, we don't put R2. If you were going to write this as an answer in your grown-up maybe 4th grade, you would say 39 and then 2 over 3, right? You put the remainder over whatever you divided by. We are going to do the exact same thing now. It's just with polynomials. Now, I'm sure you guys have seen this before. I may do it a little differently than you were taught, but that's okay. Excuse me. This says 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. So what goes outside? X minus 2. So we're going to put that on the outside. X minus 2. And on the inside is our big old polynomial. So 6x cubed minus 19x squared plus 16x minus 4. Now, before you start your division, you have to make sure that there is no gaps in exponents. What I mean by that, what's the highest exponent you have? 3. So that means every single exponent needs to be accounted for. Do you have an x squared? Yes. Do you have an x to the first? Yes. Do you have a constant? Yes. If you don't have one, you have to put 0 as a placeholder. So now we're going to do the process of long division. I'm going to say first term, underline this, first term into first term. That's what we're focused on. So I'm going to do a little side work over here. I say x times what gives me 6x cubed. What's my answer? 6x squared. So look, I'm going to put 6x squared above the other x squareds just to keep myself organized. So we divided first term into first term. We got 6x squared. So going back to our 3rd grade division, once we got that number up top, what did we do? What do I do with 6x squared now? I'm going to multiply it, right? Look how I put this in parentheses. You guys should put this parentheses every single time before you do anything. Because when you multiply here, you're going to multiply to both. So I have 6x squared times x is 6x cubed. Good. Then I have 6x squared times negative 2 is negative 12x squared. Good. And what are we doing in this step right here? We're subtracting. This is the biggest thing you have to remember when dividing using long division. If you have 6x cubed minus 19x squared minus 6x cubed minus 12x squared. Guys, what do you have to do with that minus sign before you can? You have to distribute it. You have to distribute here and here. So at this step, every single time, you have to remember to change, change, change. Once you do that, then you can go ahead and combine. So I have negative 19x squared plus 12x squared. Negative 7x squared. What happens to 6x cubed and negative 6x cubed? They cancel, and then what do? We bring down. So the exact process that we did with our just numbers, we're doing now with polynomials. And then you start the process all over again. You say first term into first term. So x times what is going to give me negative 7x squared. So look, I'm going to put negative 7x. Keep everything on top of each other so it's nice to see how my x squareds are on top of x squareds. X is on top of x. Now before I subtract, I'm going to go ahead and get this set up. So now I'm going to multiply, negative 7x times x is negative 7x squared. Negative 7x times negative 2 is plus 14x. And before I subtract, what do I have to do with that negative sign? Distribute. So I'm going to just change all of them. Change, change, change. So now we combine. What is 16x minus 14x? 2x, good. What happens to your negative x squared and positive x squared? It cancels. And what do you do with negative 4? You bring it down. Now we're going to do the same thing all over again. I'm going to say first term into, whoops, I forgot the 4, right? First term into first term. So x times what gives me 2x? 2. So positive 2. All right. Before I multiply, I'm going to get my subtraction all set up so I don't forget. And I'm going to say 2 times x is 2x. And 2 times negative 2 is negative 4. Before I go ahead and say, okay, I'm just going to combine, what do I do with that negative sign? Distribute it. So change, change, change. What's negative 4 plus 4? 0. What's 2x minus 2x? 0. So what do you notice here? There's no what? There's no remainder. So that's perfect. So your answer here would be 6x squared minus 7x plus 2. Now, if you get lost somewhere in the process, my suggestion to you is erase it and start over. It's really hard to try and find your mistake. It can be very confusing. So just start over. Monday, we're going to talk about the shortcut, and then you guys won't have to do long division. You're going to have to do one on your quiz. It'll say solve using long division. You have to do it that way. Now, a lot of you like to check your work just to make sure. How could you check this? Okay, you could multiply. You could take x minus 2, which you divided by, and multiply it by your answer. And what should you get? Whoops. You should get this polynomial here. Do you have to check it? No. Here's the opportunity for you if you want to. All right, let's do another one. What goes on the inside? What goes on the outside? X minus 8 is going to go on the outside. And then what's going on the inside? X squared minus what? God bless you. 74. Why did I put a big space there? You have to account for every single exponent, right? So if I start with x squared, do I have an x to the first power? No. So I'm just going to go ahead and write a plus 0x. You can make it a plus or a minus. It doesn't matter. But you have to have that placeholder. And then now we just go through and we say, okay, fine. First term into first term. So x times what gives me x squared? X. I'm going to put it right up here in my x column. Get your subtraction set up before you multiply. And now we can say, okay, x times x gives me x squared. What's x times negative 8? Negative 8x. Perfect. Now again, you guys are going to start to see the repetitiveness. Before you subtract, what do we have to do? You got to distribute that negative. So change, change, change. Now we can combine. What's 0x plus 8x? 8x, good. What happens with x squared and negative x squared? Cancels. And what do? We bring down. Now we're going to do the process all over again. First term into first term. X times what gives me 8x? Positive 8. So plus 8. Get your subtraction set up before you multiply. So we have x times x is x, sorry, wrong one. 8 times x is 8x. 8 times negative 8 is minus 64. And before we combine, what do? Distribute. So change, change, change. What's negative 74 plus 64? Negative 10. What's 8x minus 8x? 0. Then we bring down. Wait, there's nothing to bring down. What is negative 10? It's your remainder. So I'm just going to stick negative 10. Since it's negative 10. And what do I put it over? X minus 8, whatever you divide it by. Good. So your answer here would be x plus 8. You don't need it in parentheses. I don't know why I did that. X plus 8 minus 10 over x minus 8. Question. Now, the first one didn't have a remainder. The second one did have a remainder. Do you think that means something when something has a remainder and when something doesn't? Yes or no? Say it again. No. Sometimes you're going to have a remainder and sometimes you won't. We're going to talk about this more on Monday. But when things work out without a remainder, you've proven or you've shown that something is a factor. It's a zero. So it's like x equals whatever. Like in the first one, we divided by x minus 2. So that means if you were to solve that equation to find the zeros of the x-intercepts, x equals 2 would be an answer. All right, let's look at 3. Same thing. What goes on the outside? What goes on the inside? 2x plus 3 is on the outside. And on the inside, I have 2x squared minus 17x minus 38. Do I need any placeholders here? Look on the inside. We go x squared, x, and a constant. We're good. So first term into first term. 2x times what gives me 2x squared? Do you have to do this little side work? No. But it just keeps me organized when I do this. That's why I do it. But 2x times what gives me 2x squared? X. So I'm going to put it right here above the 17x. All right, get your subtraction ready before you multiply. Thank you. And we're going to multiply here. X times 2x is 2x squared. X times 3 is positive 3x, correct? Okay, so now before we do any of our subtraction, what do I have to do with that negative sign? Distribute, so change, change, change. So now we combine negative 17x and a negative 3x. Negative 20x. What happens to my 2x squareds? They cancel. And then what do I do with minus 38? Yeah, bring it down. Hey, guess what? We're going to do it again. First term into first term. 2x times what gives me negative 20x? Negative what? Perfect. Negative 10. So get your subtraction set up before you multiply. So now I have negative 10 times 2x is negative 20x. Yeah? Negative 10 and a negative 3, negative 30. And before we subtract, what do? Distribute that negative, so change, change, change. What's negative 38 plus 30? Negative 8. What's negative 20x and a positive 20x? 0. Is there anything left to bring down? So negative 8 becomes my remainder. It's minus 8 over whatever you multiply, 2x plus 3, or divided by. Golly. So x minus 10 minus 8 over 2x plus 3. Now, this is not a terribly difficult concept, but if you don't practice it a couple times, it is going to be hard. I didn't give you guys a ton of these on WebAssign, but it's good to just practice it, kind of go through the motions, make sure you understand. That's important. We'll talk about this as we go. All right, synthetic division. Here's the shortcut. You guys are going to say, can we just please do this every time? No. You're going to have to do one by long division, and then, yes, you can do the shortcut. Do you guys remember the shortcut? Anybody remember? Remember hearing about synthetic division? Okay, we'll go through it. All right, we're going to use synthetic division to divide. God bless you. The first thing you're going to do is you're going to set this piece equal to 0. So I'm going to say x plus 3 equals 0. So what does x equal? Negative 3. So that is what we're going to put up here in the corner of our little box. We're going to put a little box up here in the corner. You're going to figure out whatever you're dividing by. Whatever you're dividing by, you set equal to 0. And that's going to go up in the corner. Now we put out the coefficients. We list out the coefficients of our polynomial. What is the coefficient of x to the 4th? 1. What is the coefficient of x cubed? What's the coefficient of x cubed? X cubed. 0. What's the coefficient of x squared? Negative 10. What's the coefficient of x? Negative 2. What's the constant? 4. If there is not an exponent represented, you guys have to put the 0. You have to. Now with synthetic division, we're going to do the same thing every time. You're going to bring down the first number, 1. Then we're going to multiply to the corner and add down. So I'm going to multiply. What's 1 times negative 3? Negative 3. And now we're going to add down. What's 0 plus negative 3? Negative 3. Now we're going to multiply to the corner. What's negative 3 times negative 3? 9. And now we're going to add down. What's negative 10 plus 9? Negative 1. Multiply to the corner. What's negative 1 times negative 3? 3. Now we're going to add down. What's negative 2 plus 3? 1. Multiply to the corner. 1 times negative 3. And then add down. 4 plus negative 3 is 1. All right, so now you guys are like, okay, now what? Well, if we were going to divide, you guys don't have to write this down, but if I was going to divide x plus 3 into x to the fourth, blah, 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 right? I would say first term into first term. I'd say x goes into x to the fourth how many times? X times what would give me x to the fourth? X cubed, right? So what you guys have done is you have just done all of the long division, but using the shortcut of synthetic division. So this is going to be the coefficient of your x cubed. This is the coefficient of x squared. This is the coefficient of x. This is your constant, and this is your remainder. Your coefficients that you end up with are always going to be one less than what you started with, because think about it, we're dividing. You're going x into the first term. So if I was going to ask you to write the resulting polynomial here, you guys would have 1x cubed minus 3x squared minus x plus 1 over what? Would you divide by? X plus 3. Synthetic division is just a shortcut. You're actually doing the polynomial division. You just, God bless you, don't have to do the long process. Let's do another one. If I was going to divide, what would go on the outside? What would go on the inside? Yep. X minus 8 would be where? On the outside. So we're going to set this piece equal to 0. That's what's going to go in the box. X minus 8 equals 0. So you guys agree with me that x equals 8? Okay. So I'm going to put 8 out here. And then I'm going to put the coefficients of all the polynomial. And I have to have a space for everything. So first one is x squared. So it's 1x squared. What's the coefficient of x? What kind of 7? Negative 7, good. And then we have a constant, yeah? Negative 11, okay. So in order to synthetically divide, you bring the first term down. Then we multiply to the corner and add down. So 1 times 8 is 8. And then negative 7 plus 8 is 1. Multiply to the corner. 1 times 8 is 8. Negative 11 plus 8 is negative 3, right? So your resulting polynomial is right there. It's the coefficients. Since I started with x squared, what does my answer start with? X. This is x, your constant, and your remainder. So if you were going to write it, it would be x plus 1 minus 3 over, what did we divide by? X minus 8. Now we're going to use synthetic division a lot on Monday to discover if things are factors of each other and that sort of a thing. But synthetic division, it's a lot easier for you. All right, what do I put in my little box? What goes in the corner? Negative 5. We set what we're dividing by equal to 0, so y equals negative 5. Y equals negative 5, so that's going to go in the corner. And then I write out my coefficients. Make sure everything is accounted for. So we start with x squared. What's the coefficient of, y squared. What's the coefficient of y squared? 1. What's the coefficient of y? 10. And then what's the constant? Perfect. How do we synthetically divide? You bring down the first term, multiply to the corner, and add down. So 1 times negative 5 is negative 5. 10 plus negative 5, or 10 minus 5 is 5. Multiply to the corner. 5 times negative 5 is negative 25. Add down. What's 18 and negative 25? Negative 7. All right, there's the coefficients of your polynomial answer. Read it to me. What does that say? X plus 5 minus 7 over y plus 5. Good job. Very good, guys. This should be a y. I just make everything x's. Side note, I did this yesterday with Algebra 2 Honors. These poor kids, they started WebAssign, and it's factoring. So they're factoring these really hard problems. but it had like T's and S's, so I changed them all to X's, and they kept putting their answers in, and they're like, it keeps marking it wrong, because they were putting in X and they didn't use the letter. I felt so bad. I'm like, my bad, guys. So whatever letter they use, you guys have to use. That's frustrating now. All right, remainder theorem. Last thing we're going to talk about. You guys, we've already done this. You guys will understand this in 2 seconds. Remainder theorem. When you are asked to evaluate using the remainder theorem, what do you think the only part of the answer they care about? The remainder. Okay? When they say using the remainder theorem, all that means is what is the remainder? That's all they're asking you to do. So we're going to use synthetic division. They're going to tell you what to use to synthetically divide, what to put in the little box, and then you're going to answer, hey, here's the remainder. So we're going to set up like this. They're saying to take -2, right? We're going to put -2 in our little box to synthetically divide. And we're dividing it into 3x cubed plus 8x squared plus 5x minus 7. So coefficients. What's the coefficient of x cubed? 3. Coefficient of x squared. Coefficient of x. Perfect. And then the constant. So synthetically divide. We bring down the 3. Excuse me. Multiply to the corner. 3 times -2. -6. And then we're going to add down. What's 8 and -6? Perfect. Multiply to the corner. 2 times -2. -4. Add down. 5 and -4. Perfect. Multiply to the corner. 2 times -1. -2. Add down. -9. What is the only thing that matters here? The way that you would answer this when it says using the remainder theorem is you say f, p, g. It doesn't matter. But f of -2 equals 9. What -9? What you're saying is what that says right here. When I synthetically divide by -2, my remainder is -9. That's how you guys need to answer. So if we look at the next one, what do they want me to put in the little corner box? A 1. So I write out my coefficients. What's the coefficient of k squared? 1. What's the coefficient of k? And what's the constant? Okay. Bring down the first term. We multiply to the corner. 1 times 1 is 1. What's -7 and 1? -6. Multiply to the corner. What's -6 times 1? Add down. 10 and -6. How do I answer this question? K of 1 equals 4. Perfect. It doesn't, you can use whatever letter you want. I don't care. I just use K because it was different than X. Don't say X of 1. Do F of G, any letter but X. X or Y. All right, what do I put in the corner here? 5, good. Let's list out the coefficients. What are they?
1, 1, 0.
Ooh, look at you. Good job. Why do we have a 0 here? Because there is no a to the first power. If you guys forget the place marker, the 0, it'll screw up your whole answer. So just pay attention. Synthetic division. Let's get the party started. What's 1 times 5? 5. Then we're going to add down with 0 plus 5. 5. What's 5 times 5? And -28 and 25 is? So your answer here is G of 5 equals -3. A of 5. What I'm saying is I don't care what letter you use. What you're saying is, hey, when I synthetically divide using this number, this is my remainder. Now, when the remainder is 0, we'll talk about this more on Monday, that means, ooh, this is a factor. You can then write your resulting polynomial, and you'll be able to factor that more. We'll talk about that later. All right, we good?
Yeah.
That's it.